Alright, so when we start to talk about isomers, it says take a moment to draw the complete or condensed structural formula for C4H10. When I have 4 carbons and 10 hydrogens, I just list them out. And so hopefully we've been talking about alkanes and alkenes and alkynes. There's no indication here that this has a double bond in it anywhere. So if I were to draw this out, it looks like I just get butane. There's 4 carbons. And then if I start counting my hydrogens there, I have 10 hydrogens. Now, the question is can I draw this a different way so that I still have 4 carbons and I still have 10 hydrogens, but it's no longer butane. It has a different name to it. Pause the video, think about it, try to make a couple sketches on the side, see if you can't make another structure that's not butane that has 4 carbons and 10 hydrogens. And when you're ready, come on back. Alright, so could it be drawn a different way? Well, the only thing really that we can start to do here is we can really start to take carbon chains on the end and let's see what would happen if it were maybe moved over one. Well, if I were to move this over one, I'd have something like CH3, CH2, CH2, and then if I branched it up instead, CH3, maybe you tried that one. Well, it's a good try. But this one, actually, if you look at it, still leads the same longest carbon chain, right? So it's still butane. So I need to figure out maybe another way of drawing this out such that that carbon is no longer part of the parent chain. And as soon as I say no longer part of the parent chain, normally that gives a pretty good indication that it can't really go on the ends anywhere. So the only place left is what happens if I tried to put this in the middle. And so what if I had something that was maybe like this, right? That gives me 4 carbons, but does it give 10 hydrogens? And so sketching this out, I can see down here that I've got 3, 6, 9, and then one more there would make 10. So it does work out, and the name of this would just be 2-methyl propane. Right, showing up on the second carbon. Out of a 3 carbon chain now, it's no longer butane. So by taking the same number of carbons and hydrogens, I was able to come up with a new compound, a new structure that has a different name to it, has different properties. So as we'll see here, even though both compounds have that same formula, C4H10, things like their boiling points and other properties are different. They're different substances altogether. Compounds that have the same molecular formula but different molecular structures, that's what's known as isomers. So they still have the same C4H10, but they have different names to them. So these ones are examples of structural isomers, and we're going to take a look at a couple different types, but these ones are structural isomers. So they have the same molecular formula, but their atoms join in different order. And like I mentioned, they have different properties, things like melting points, boiling points. So in general, the more branches, then the lower the boiling point it would have. And remember, we start to talk about boiling point, meaning the lower it would have before it turns into a gas. So when there's a double bond between the carbon atoms, it prevents them from rotating. And if you think about the models that we had, if you start to put a double bond in there and try to spin the 2 carbon atoms that are attached with the double bond, they don't really turn very well. It's like they want to kind of spiral on each other, but they can't. Geometric isomers, they have atoms joined in the same order, but in different orientation of groups around the double bond. So geometric isomers are a little bit different than structural isomers. Notice again, they have atoms joined in the same order, but they have a different orientation. They look different. So to see this, let's build 2-butene with the models and to see, can you build it in a different way. So let's get the model kits, pause the video and see if you can draw 2-butene and build 2-butene, and can you build it so it looks different, its orientation is different. And we'll give you a second with that and then come on back. Alright, so with 2-butene, if I were to draw them out on the board, what we should see as you were building them is that you'd start with these carbon-carbon double bonds. Then you could build it so the two carbons were facing in the same direction or in the same plane. Okay, if I kind of imagine this part in the middle as being like a rotation piece, they're in the same side. Likewise, I could have my carbon-carbon double bond, and I could have had one carbon up on the top and one coming down on the bottom. And so in this case, what I have is, again, in this plane, now when I rotate this, they're on opposite planes all the time. And so those are called geometric isomers. So the trans configuration, the methyl groups are on opposite sides. And so if we look back on what we just drew, on opposite sides I have the trans configuration. So this would be my trans configuration. The cis configuration, the methyl groups are on the same side. So over here I have my cis configuration. Okay, cis and trans isomers. So, and you can see the names here, trans 2-butene, cis 2-butene. And notice the ENE ending, where the double bond happens at 2, and then it says if it's trans or cis. They would be called geometric isomers, and they have different chemical and physical properties based on which isomer type it is. So they're possible whenever each carbon of the double bond has at least one branch coming off, at least one substituent. And in this case, it would be a cis or a trans configuration. So, as an example, to use the models again, build the cis and trans geometric isomers for 2-pentene. Then, let's see if you can draw the condensed structural diagrams for each one. So, the cis and trans isomers for 2-pentene. So, pause the video and give it a try. Alright, so our pentene chain normally 5 across, and it has a double bond at 2. But now it's saying, okay, include in it the cis and trans structure for geometric isomers. So pentene, I have a double bond at 2, and then I'll have one going up, and then the other one continuing that pattern going up. I could fill them in with the carbons the same way, or the hydrogens, sorry, the same way we did before. And I should also note that it's fairly common as well to see the hydrogens surrounding the double bond, these ones, kind of being shown in like an X pattern to show where the cis and trans configuration are for these. And then, so in this case, they're on the same side. So same side, I have my cis configuration. So cis 2-pentene. And then over on my other side, I'm going to have my double bonded carbon. And then where I had them in the same plane here, I'm going to separate them out and put them in different planes on this side. So in this case now they're in opposite sides. I have my trans 2-pentene. So from here there is a little worksheet to go through, just alkanes, alkynes, isomers, to go through and name and draw and try to figure out a couple different patterns and that sort of thing. There is on the notes I should add in a little review and a recap that might help kind of, just start to form everything. It's good for kind of summary of notes at the end, just to keep everything straight in your head. I didn't mention the general formulas for alkenes and alkynes, but they are there. So we talked about the general formula for alkanes, that's CnH2n plus 2. And then you can see alkenes, when I have a double bond, it just takes away 2. And then alkynes, the triple bond, it takes away 2 more. And so if there's examples, it's a good little table to reference. So with the last slide here as well, we have a little bit of a video review, alkanes, alkenes, alkynes, and kind of more of a realistic thing. How does the body lose fat? If you think about what we just talked about with cis and trans isomers, maybe you've heard of trans fats before. That's something that would obviously be connected in terms of what we understand about chemistry and how it applies to our real world. So work on the worksheet, and then once you finish that, we'll move on to the next section from the website directions.